Okay, let's start. Let's start. So last week we have started statistic now. Statistic, especially we discussed about mode, median, and just definition of mean. Just definition of mean. Okay. Then today we need to go further with mean, standard deviation, variance, and that means measurement of dispersion. So I told you statistic mean data collection, arrangement, and analysis. Statistic mean data collection, arrangement, and analysis. Then no data collection in A levels, then no data arrangement in A levels, no data analysis in A levels. But we have only calculation part. Then that calculation done by two techniques. One is compression technique. So by compression we consider about central tendency measurements. So under central tendency measurement we had done mode, median, and mean. Mean, median, mode. Okay. Then specially mean we have to calculation. We have calculations to analyze, and there are some proof here. Okay. Now further we have analyzed three different types of data sets. So here it is. So a data set like x1, x2, x3, xn. Here this is we call ungrouped data distribution. Ungrouped data. Then with frequency x1, f1, x2, f2, x3, f3, then xn, fn. Then here this arrangement we call ungrouped frequency distribution. Ungrouped frequency. Ungrouped frequency distribution. So here actual data mentioning here, and here also actual data there. But for huge data set we consider L1 to L2, then data collection we have frequency f1, then L2 to L3 frequency f2, L3 to L4 here frequency f3, likewise Ln to Ln plus 1 frequency fn. Then here this data set we call group frequency distribution. Group frequency distribution. So we have three different types of data collections. So here we're going to analyze mean. So mean just average. We have different types of means. So when you consider first type of data, here first set, so we have arithmetic mean first. Mean. Here mean. Arithmetic mean we say x1, x2, x3, xn divide by n. We call average. Average, usually we denote by x bar. Then arithmetic mean we say average, then that denote by x bar. And further we have geometric mean. So geometric mean here 1, x1, x2, x3, xn divide by 1 over n power. Here average no, then addition divide by n, we get arithmetic mean. Then geometric mean you get multiplication and get 1 over n power, geometric mean. Here there's special thing, arithmetic mean always greater than or equal geometric mean. Then don't worry about this geometric mean and all the other means, but we need to know only arithmetic mean. Okay. Now further we have harmonic mean. Then harmonic mean relation 1 over harmonic mean equal 1 over x1, 1 over x2, 1 over x3 and so on 1 over xn divide by n. This is we call harmonic mean. 1 over harmonic mean equal mean of the reciprocals, harmonic mean. Then we have further square mean. Then here x1 is square, x2 is square, x3 is square, xn square divided by n. Here is square mean. Then likewise we have different types of means. And another one, 5, weighted mean. Another mean type. So you consider x1 its weight w1, x2 weight w2 like frequency, okay? Then xn weight wn, these are like frequencies. Therefore, here weighted mean equal x1 times w1 plus x2 times w2 plus xn times wn divided by w1 plus w2 plus wn. This is we call weighted mean. It's like frequency. Weight mean like frequency. So these are different types of mean in our statistic lesson, but we need to consider only about arithmetic mean. Okay. So I just explained about mean last day. Then we need to go further with that mean today, and further with variance, standard deviation, and so on calculations. Okay. Then you start from here. You put this note first. Put this note first. Don't worry about other means, but there are these type of means. Okay. Now let's see further mean calculation procedure. Now do with me. So you consider x1, x2, x3, xn data set. Here arithmetic mean we denote by x bar. Write with me. Then that is we call sigma I equal 1 to n xi divided by n. This is we call arithmetic mean. Therefore, just example, here 1 plus 1, 2, 3, 4, 5, 6. Then x bar mean 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. Here 7, 14, 21 over 6. 7 over 2, 3.5. Likewise, you can calculate mean. Okay. Then for simple numerical values, this calculation is simple. But for large numerical values, it is somewhat difficult to calculate for large values. So here we define DI, we call deviation, that is denoted by xi minus a. Here for easy calculation. For easy calculations, DI equal xi minus a. DI we call deviation. A we call assumed mean. Okay. Then according to that, we get xi equal di plus a. No? Therefore, you say x bar equal d bar plus a. So this thing I have given last week, x bar equal d bar plus a. So here the procedure, sigma I equal x bar equal, here proof, x bar equal sigma xi divided by n. Here I equal 1 to n. I equal 1 to n divided by n. Then here xi equal di plus a, you put here. Then sigma di plus a divided by n. Di plus a divided by n. Now, here you can split sigma. Then x bar equal sigma, here di, separate denominator, divided by n, plus sigma, here constant, no? Sigma a divided by n. Sigma a divided by n. Likewise, we can split it. So, thereafter, we can further simplify. Then here, for this one we say x bar, no? For this one we say x bar. Then for this one we say d bar. And here sigma a mean, here I equal 1 to n, I equal 1 to n. Here I equal 1 to n, a. Then here constant term addition, n times addition, we say n a divided by n. Then x bar we get d bar plus a. We say this is for easy calculations. Okay, put that technique and especially this proof. Later we will see how to apply it. You do this in a separate paper. Here is proof for mean with this with deviation. Here the data set ungrouped data distribution, that means mean for ungrouped data distribution. That's how we do. Okay, later we will see how this simplification get easier than the previous one. Later we will see, but by the equation we can't see. The calculation, but this is too easy to calculate. Further this we can extend that. Further we can extend this. Okay. Then for further easy calculations, you define new variable yi, that is we call xi minus a divided by c. So we have to divide that difference again by a constant. Therefore, here xi equal cyi plus a. Then according to that, x bar equal cy bar plus a. Same format it goes. Then here further simple calculation procedure. Then here let's say proof x bar mean sigma xi divided by n. I equal 1 to n. Then for xi you put this one here. Then sigma I equal 1 to n cyi plus a divided by n. Now separate denominator and sigma. Then x bar equal, here take c outside, sigma I equal 1 to n yi divided by n, and sigma a divided by n, I equal 1 to n. Then for this part we say y bar. For this part you say y bar. Then here constant addition na divided by n. Then cy bar plus a. Then x bar equals cy bar plus a. X bar equals cy bar plus a. This is further calculation simplification process. Okay. Later we will see how to get that procedure. Okay. Write that one as well. Okay. Now let's do same thing for group frequency distributions, or otherwise frequency distributions. There are two types of frequency distributions now. Then mean for frequency distributions. Better to do with me. Here let's say x1 frequency f1, x2 frequency f2, x3 frequency f3, xn frequency fn. Then mean x bar equals sigma I equal 1 to n fi xi divided by sigma I equal 1 to n fi. This is we call mean. Here general formula. So see example. You consider xi, fi, here 10, 12, 15, 16. Then frequencies, let's say 1, 5, 2, 3, 4. Then mean, x bar mean sigma fi xi divided by sigma fi. Then you take frequency sum 5, 7, 13, 10, 14. Here this is we call sigma fi. Then 14. Then we need sigma fi xi. You get another column, fi xi column. Multiply 50, 24, 45, 64. Then get addition 3, 183. Then you can get mean value. That's how we calculate. But I am telling here, this procedure is somewhat difficult. Therefore, we need coding method. Okay, do up to that. Here general formula. This is general formula. Okay, now let's move for easy calculations. Here we define di variable xi minus a. Same procedure like previous one. Di. We call deviation. So these things you have done under O levels. Okay? Deviation. A assume mean. Therefore, here we get x bar equal d bar plus a. Then see proof. See this proof. Then after this we can do examples. Then x bar mean sigma I equal 1 to n fi xi divided by sigma fi I equal 1 to n sigma fi. Okay, this is general one. Then by this one you can get xi equal di plus a. Put that one here. Instead of xi, you put that. Then x bar equal sigma fi, xi mean di plus a. Sigma fi. I equal 1 to n. I equal 1 to n. Okay. Then expand this bracket and separate sigma and separate denominator. Same time you do all. Same time you do all. Now here it is. X bar equal sigma fi di divided by sigma fi plus here fi a, no, take a outside, sigma fi divided by sigma fi. Sigma fi. Okay, do with me. Do with me. Here this is we call d bar and you can cancel fi. Then d bar plus a. That's how we prove for group frequency distributions. Or any frequency distribution proof we can do by that method. Then anyway, everything comes under sigma notation, no? Sigma notation. Then with the sigma property we do these things. Then further we can simplify these calculations. Here we define yi variable xi minus a divided by c. Usually we say c mean class width. Class width. This method we call method of coding. Method of coding. Method of coding. So here xi equal cyi plus a. Cyi plus a. Then x bar we can write cy bar plus a. Same procedure we can write this. X bar equal cy bar plus a. Then see proof. See proof. Now x bar equal sigma fi xi divided by sigma fi. No? I equal 1 to n. I equal 1 to n. Then x bar. Here sigma fi xi, write cy by plus a. Cyi plus a. Sigma fi. I equal 1 to n. I equal 1 to n. Now separate, expand this bracket, separate sigma and separate denominator. Do at once. Then x bar equal c sigma fi yi. Sigma fi plus a sigma fi divided by sigma fi. Now cancel fi. Here this is we call y bar. X bar equal cy bar plus a. That's how we prove. This transformation we call linear transformation, especially method called method of coding. Then anyway, it is like y equal mx plus c type. Then linear transformation, another word for that. Linear transformation. Okay, write them all. Okay, now let's check this with example, all calculations. Okay, you start doing with me. Now take 2023 question table. I'm going to take that. 2023, better to copy it. Here time 0 to 10, 10 to 20, 20 to 30, third to 40, 40 to 50. Then number of students, you can denote that one by frequency F5. 10, 20, 35, 20, 15. Here xi mean class mark, here mean value 5, 15, 25, 35, 45. Then here addition, sigma F5. Here 30, 65, 80, 100. Then general procedure, we need to get Fi xi. Then multiply 50, 300, 25 into 35. 57675. 700. 45 into 15. 675. Then take sigma Fi xi. Then here 1000, 1200, 1300 and 50, 1400. 1400 හරිනේ 1000 1000 2200 2300 2350 2400. Therefore, now mean sigma Fi xi divided by sigma Fi. Then 2400 divided by 100. 24. Okay, check values. $875, 206, 2600. No? Then 26 mean. 26 mean. Now, here let's move to second case. Second case. Then here we have to define di variable. Xi minus a. Xi minus a. Then here d by x by xi equal di plus a. Then x bar equal d bar plus a. Then here we have to get assume mean. So we know surely mean within this range. Therefore, you take mid value. Here you better take mean as the mid value. Usually mean somewhat close to mean mid value. Then you take assume mean, that is a. Then you take di variable, di column. Then here xi, here a. Then xi, a both coincident here. Then xi minus a, di equal xi minus a, 25 minus 25, 0. Then xi minus a, 15 minus 25 minus 10. 5 minus 25 minus 20. 35 minus 25, 10. Here 20. Then d bar means sigma Fi di divided by sigma Fi plus a. This is x bar. Now we know sigma Fi. We know assume mean 25. Then you take column fi di because we need sigma fi di. Then multiply these two, minus 200, minus 200, 0, plus 200, 300, then get addition. This is we call sigma fi di. 200, 200 cancel, here 100. See, sigma fi di 100, 26. බලන්න කලින් එකට වැඩිය මේක කැල්කියුලේෂන් ලේසුණා අන්නේ. කලින් කේ අර එරර් එකකුත් උනා මේක මෙතන කරන්න කියලා පැත්තකින්. දැන් වෙනම වර්ක් එකක් කරලා යන්න ඕනේ. But here we don't need that. Then that's why I told you that becomes to easy calculation. Then further we can further simplify that calculation using yi variable. Yi equal xi minus a divided by c. Then xi equal cy plus a. According to this, x bar equal cy bar plus a. Cy bar plus a. Then here c sigma fi yi divided by sigma fi plus a. This is for second case. Here first case. Here first method. Now here second method. Now here third method. We have to practice only this one. We have to practice only that one. Third method. Now you consider yi variable, that is xi minus a over c. Here a, xi these values, c mean class with 10. Then 25 minus 25 divided by 10, 0. 15 minus 25 divided by 10, minus 1, minus 2. Then here plus 1, plus 2. Then here we need fi yi column. Fi yi column. Now see fi yi minus 20, minus 20, 0, here plus 20 and 30. Then get addition. Here we get 10. Then this is sigma fi yi. Then c value 10, sigma fi yi 10, sigma fi 100, assume mean 25. Now we get 26 mean. Now you see, here further calculation has simplified. So here general one fi xi divided by sigma fi we can do, but for then the other one di variable, that calculation become very easy. Then further by introducing yi variable we can simplify further. Then that simplification process very simple now. That's how we calculate. That's how we calculate. Okay. Okay. Do that one as example. Complete it. Okay, now let's practice further. So now when we doing this calculation, we have to extend here definitely. Here class intervals will be given and frequencies will be given. Then you have to get xi column. Then don't worry about sigma fi xi di, fi di. You take yi column and fi yi column. And later we will need fi yi squared. Then fi yi square column we need. Later we'll need this fi yi squared. That's all for statistic. Then definitely this one given, then you calculate, you get xi column and you get yi column, get fi yi column. By that we can find mean. And you further extend fi yi square, that for later purposes. So that is for variance and standard deviation calculation. Okay. Now let's practice. You take 20, 22. 2022. Don't read the question, just get the table. Don't read it, just get the table. Diameter, here frequency F5, 2 to 6, 6 to 10, 10 to 14, 14 to 18, 18 to 22. Then F5, 258, 41. Get XI column, here mean value 4, 8, 12, 16, 20. Then get addition 5, 7, 14, 15, 20. That is sigma F5. Now you get mid value as mean, assume mean, say A. Then you get yi column, xi minus a over c here 0, xi minus a over c minus 1, minus 2, 1, 2. Then you get fi yi column, for fi yi minus 4, minus 5, 0, 4, 2. 4, 4 cancel, minus 3. This is equal fi yi. Then later we need fi yi square. Then you just find them again. Then fi yi square multiply 8, 5, 0, 4, 4, get addition 8, 16, 21. Sigma fi yi square. So this simplification very strong, very strong simplification because of this coding method. Now mean C y bar plus A, C mean class with 4, y bar means sigma fi yi minus 3 divided by sigma fi 20, A 12. So here it is, here 5 minus 0.6, 12, 11.4, 11.4. Don't worry about this column, later we will need that. So likewise, easily we can calculate mean. Usually you try to obtain values for 1 decimal place, that's enough. Huh? Okay. Now let's do another 2 or 3 mean calculations. Go to 2017, 2019, 2019. Okay, do soon. Do soon. No need to read the question. No need to read the question. Just do mean calculations. That's all. Huh? Just do mean calculation. Calculate xi, here 10, gap 20, 10, no? Then 20, 30, 40, 50. yi column, here mid value take as A, then 0, minus 1, minus 2, 1, 2. F5 yi column, F5 yi square column. We need addition for these 2 and this. Then F5 yi minus 18, minus 11, 0, 10, 12. Then get addition 22, 4, 11 means 7, minus 7. 22, here plus 11, then minus 7. Then here 20, 30, 40, 50. Sigma F5 yi, then F5 yi square, 36, 11, 0, 10, 24. Sigma F5 yi square. Then x bar, cy bar plus a, c min class with 10. So you need here real boundaries. These are real boundaries. Then no worries. C 10 y bar sigma F5 yi minus 7 over 50. Assume mean 30. One point minus 1.4. 18.6. 18.6. Then very easy calculation for mean. So for mode also we had same. For median also we had same. No? Very easy calculation. Okay, then go to 2005 table. 2005 table, don't read the question. Just calculate only mean. Just calculate only mean. 2005. Thirty, 34, 35, 39, 40, 44, 45, 49, 50, 54, 55, 59. Frequency F5, 5, 10, 15, 30, 5, 5. So here this is somewhat special. That specialty is here not real boundaries are given. No? Here there's small gap here. 30 to 34, then 35 to 39 there. Therefore you get real boundaries. Plus boundaries. Then here separation 1, then 0.5, 0.5 distribute among each class. 34.5. Then here 34.5, 39.5, 39.5, 44.5, 44.5, 49.5, 49.5, 54.5, 54.5, 59.5, here 29.5. Now here class width you have to obtain from here. Class width, now here 5, not 4. Then we have to get real boundaries. Now you follow same procedure. Xi, class mark 32, 37, 42, 47, here 52, 57. This is class mark. Now you get mid value. Here we don't have mid value, no? Then you take any one as A. You better take this. Here we don't have any mid value, but you take mid value close to mid as A. Then yi column, xi minus A over C. Xi minus A over C 0, minus 1, minus 2, 1, 2, 3. Then fi yi squared. Minus 10, minus 10, 0, 30, 10, 15. fi yi square 20, 10, 0, 30, 20, 45. Get additions 30, 50, 95, 105, 125. 10, 0, 5, 35. 10, 40, 50, 60, 70. 70. Then x bar, C y bar plus A. C class with 5, y bar sigma fi yi 35, divide by sigma fi 70, assume mean 42. Now you can take the numerical value. $44.5. You practice alone. Here the specialty, not real boundaries are given. Then you have to get real boundaries first, because class width we need to take from the real boundaries, not from here. But mid values, that means class mark we can obtain by this or this, whatever it is, okay. But class width we have to take from the real boundaries. Okay. Now you think this. Now we know how to calculate mean. So we have a class. Now we have marks. Then we can calculate mean. Mean we can calculate. So now already we have calculated that mean. You consider here there's a class for distribution. Here mean x bar 1. Number of elements n1. So you say there is another class, there is another one. Another class with mean x bar 2, n2, it has calculated. See another class, x bar 3, n3. Now we're going to add them together. So we need to add them. So we can't do from the beginning. We can't do calculation from the beginning. Now we have already calculated 3. Now let's see how to get pool mean. This is we call pool mean. Now here total elements, addition of these 3, addition. Then n1 plus n2 plus n3. Then take new mean x bar n. X bar n. Then here the procedure x bar n equal here x bar 1 times n1, x bar 1 times n1, here total value. Here total value x bar 2 times n2 plus x bar 3 times n3. Now we need to get average of that. n1 plus n2 plus n3. This is we call pool mean. Pool mean. So if we need to gather 2 or more classes, 2 or more distributions, if we need to get that mean value, we can do this formula. Okay. You think there are 10 students. Then here mean calculated now 15, 45. Then 20 students, we have mean calculation 35. Then we have another 10 students, let's say 5 students, we have calculated that for 50. Then pool mean 10 times 45, 20 times 35, 5 times 50, divide by 10 plus 20 plus 5. This is we call pool mean. Then we can do calculations very easily. Okay. Write this on pool mean. So if you have tutorial, just write last page that is given. Last page means theory. Page number 9. Page number 9, last page. Page number 9, last page. In that space, you better write this on pool mean. Don't write example there, because we need to get the other one, pool variance, we need to write there. Just write only pool mean formula. Now let's see one application of that. Now again go to 2005 question, 2005 table. Now just read it. So total 100 students. Passing mark 30. Then marks less than 30, they are fail. 2005, that previous question. Now here this distribution given 30 to further marks, no? Then here all are given for pass students. So now we have altogether 70 student pass. Then there are 30 student fail. Okay, 70 student pass, 30 student fail. Now we have calculated pass student average. Here pass student average. And already given there are 100 students, they are mean 38. Variance also given, but don't worry about that. But anyway, you got 100 student mean 38. Then all full collection mean value 38. You have to calculate failed students mean. Okay. Now let's do it. Now let's try to gather it. Let's try to gather it. Now here we have pass students and failed student. Pass 70 students, then mean x bar 1, 44.5. 44.5 we have calculated this. Then failed students 30, then this is unknown, x bar 2. Then full collection n1 plus n2, 100 students, then new mean 38. 38 given. 38 given. Then we have to calculate failed student mean. Then here x bar n equal 70 times 44.5 plus 30 times x bar 2 divided by 70 plus 30. Here the thing, no? Then x bar n given 38. Then we can easily find x bar 2, no? Now obtain the value. Okay, do it now. That's how we get pool mean. So past student calculation we have given, we have to calculate that previously we done. Then full student collection, 100 student mean given, then you have to calculate failed students. Using pool mean you can subject it, no? Okay. That is about pool mean. So later we have to discuss pool variance. So still we haven't come to measurement of this dispersion. Okay. Now let's move a little further. Okay. Okay, now come to this, that pool mean, very important thing. There's another important thing now. Think, now we have a class, we have marks, now we have calculated mean. We have calculated mean. Now finally, it is given that we have to add 5 marks for each student. 5 marks by each student. Then thereafter we have to do all calculations now. No? We have to do all calculations because all the full data set has changed. But there's property, when we add constant value for each one, then mean also we can do same. Mean also we can do same. So when we multiply by a constant value, then also mean also we can multiply by constant value. That is called linear transformation. So here it is, okay. Now you think our data set x1, x2, x3, x4, xn. Here this is our data set. Then here x bar. Then now we have to add constant x1 plus b, x2 plus b, yeah, x3 plus b, xn plus b. Then new mean x bar n we call previous mean x bar, no? X bar plus b. That's it. That's it. When we add constant value for each element, then mean also we need to add. That's it. So let's say we're going to multiply by a constant value x1, ax2, ax3, axn. Then new mean x bar n will be here x bar times a, ax bar. Okay. So here first set, here second set. So if you do both at once, ax1 plus b, ax2 plus b, ax3 plus b, axn plus b. So we have marks, we have to transform that mark, you have to multiply by 2 and add 1. Then 2x plus 1, no? That is linear transformation. Therefore, previous mean, by previous mean we can calculate new mean. Then 2 times previous mean plus 1, no? 2 times previous mean plus 1. So here our data set we have calculated mean, this is already calculated. Then finally it says that we have to add constant value for each student. Then no need to do all calculations now, you can just add constant value for mean. So when we multiply by a constant value each mark, then same way you can multiply by same constant. So if you do that both at once, then x bar n we can say ax bar plus b, ax bar plus b. This is we call linear transformation. Linear transformation. Linear transformation. Okay. Then let's see how to prove this. X bar mean sigma xi divided by n, no? Sigma xi divided by n. Then x bar n, first case x bar n, then here sigma. Now x I plus b, instead of xi you put xi plus b divided by n. This is new mean now. Now separate sigma. Sigma xi over n, sigma b over n. We have n element. Here this is previous x bar. Now here constant b addition b times n divided by n. X bar plus b. That's how we get it. Okay. When we add constant value for each element, then mean also change same way. Same way. Okay. Do that one, do this proof, and you try to prove the other two. Try to prove the other two. Okay, do it. Next case, second case, x bar n, sigma a xi divided by n, take a outside. This is previous mean. Then third, sigma axi plus b divided by n, separate sigma. here be n divided by n. Okay, now we have done many things. So first one, we have identified what is statistic. We have identified what is statistic. Thereafter, we arrange collected data. Okay, we arrange collected data, ungrouped data distribution, ungrouped frequency distribution, group frequency distribution, 3 different types. Then for group frequency distributions, we have sketched different graphs: frequency polygon, histogram, and Ogive. Okay, using Ogive we can obtain median. We can obtain median. So using histogram we can obtain mode. No, we can calculate mode. Then thereafter we analyze things about mean of a distribution. So that can be frequency distribution or non-frequency distributions. Whatever it is, okay, we can calculate mean. Okay. Then while doing mean, we did another few simplification things. For easy simplification, we have done coordinate method. No, coordinate method. Thereafter, we have calculated collection. We have another thing. We're going to add them together, pool mean relation, pool mean. And initially full distribution given, then when we change something to that each element, then we have see what has happened, what will happen to the mean. When constant is added, then mean also we have to add constant. When multiplied by constant, then mean also we can multiply by a constant, so on. No? So those are the things. That is about central tendency measurements. So we centralize things. Mean one value. We have only one value mean. So median mean only one value. Mode can be 2, usually can be 1, 2 or 3, but not more than that. Okay. Then those are central tendency measurements. Now here further we have measurement of dispersions. That is another thing. So for your A-levels, definitely you will get mean calculation. Definitely you will get variance or standard deviation calculation. Sometimes you get mode, sometimes you get median, and so on. Okay. Okay. Now see this one, measurement of dispersions. The previous one, central tendency measurements. Now we have to expand the data set. We have to expand the data set. Here lowest element, here highest element of the distribution. Let's say mark minimum mark 10, maximum mark 80. Likewise. Then lowest mark 10, highest mark 80. Then this gap we call range. Then range. H minus L. Here one thing. So now mid value we call median. So if we divide that into another two equal part, these are we call quartiles, Q1, and this is we call Q3, and median we call again Q2. Here first quartile, second quartile, third quartile. Second quartile again we can say median. Or this one we say lower quartile, here upper quartile. Okay. So we have calculation of median, then likewise we have quartile calculation. So here we have quartiles, deciles, percentiles, 3 different things. So if we take segments of 4, we say quartiles. If we divide that into 10, we say those are deciles. If we divide that into 100, then we say they are percentiles. So anyway, here this gap we call interquartile range. Q3 minus Q1, interquartile range. Q3 minus Q1, interquartile range. Then third one, quartile deviation. That is Q3 minus Q1 divided by 2. This is called quartile deviation. Central tendency measurements are too easy to identify. But measurement of dissipation, some are easy to understand and some are difficult to understand. Okay. So here quartile deviations. Then quartiles Q1, Q2, Q3. Deciles, we have D1, D2, D9. Percentile, we have P1, P2, P3, P99. So if we have large data set, we better to get percentiles. If you have some medium level data set, we better to get deciles. For short data set, we better to get quartiles. So using them, we can identify distribution, how the data has distributed. Okay, this is quartile deviation. Okay, now for quartiles we have formula. Quartile for grouped frequency distribution. We have quartile formula. Let's see what is that. So for median I gave L1 plus C median L1 plus C n over 2 minus Fc divided by Fm. No, this is median formula. Now quartile formula, you say here now Q1, Qi. So we have to divide that into 4 now. Then you divide this one by 4. So we have 3 quartiles, 1, 2, 3. Then for I, we have 1, 2 or 3. No? Then further you write L1, see here I times n over 4. So if you need first quartile, you put I equal 1, then Q1 equal, I know, then Q1 equal L1 plus C n over 4 minus Fc over Fm. Then if you need second quartile, you put I equal 2. Then I2 equal L1 plus C 2 times n over 4 minus Fc over Fm. If you need third quartile, you put I equal 3. Then this is quartile formula. Then we can discuss how to calculate it. Huh? Okay, you better to write it. Measurement of dispersion. Page number 7 එකේ පොඩි ස්පේස් එකක් තියෙනනේ යට variation measurement of variation part එකේ එතන A space එකේ ඔය ටික note කරගන්න. මේ part එක note කරගන්න. ඒකේ අර topics තියෙනවා නම් ඒවා යටින් ගන්න නැත්නම් මේ ටික side එකකින් note කරගන්න. Measurement of variation page number 7. Okay. Further we have fourth one mean deviation, fifth one variance, and sixth one standard deviation. So we have another 3 parameters. So definitely you get variance or standard deviation, not all the others. Sometimes there can be here quartile deviation or interquartile range. Then others no need to worry about the other thing. So we need to calculate variance, standard deviation, or interquartile range or quartile deviation. Here variance, standard deviation so close. Standard deviation equals square root of variance. Square root of variance, positive square root of variance. Standard deviation we have defined, positive square root of variance. Then you better to write these parameters again. Just write, just introduction of measurement of dispersions. We have to discuss variance, standard deviation now from the beginning. Just write, for now just write. Okay, now let's finish this. Let's finish quartiles and range and these things, and later we can come to the other case. Go to 2000 A-level question table. Just read it. 2000 A-level question. Just read it. Table given. There's a table given. So that is descending order set, no? Descending order. So I told from the beginning, at the beginning I told you, we have to rearrange it, no? So it's asking median, first quartile, third quartile, mean, standard deviation, coefficient of skewness. Later we will discuss them. Then let's calculate quartiles and interquartile range for that. Okay. Then all the other questions I haven't seen quartiles. Okay, all the other question I haven't seen quartiles. Then that came 2000 year 2000 only. Okay, anyway, just calculate it. Okay, now start doing with me. You get new paper and first write class intervals, lifetime, then 50 to 54, 55 to 59, 60 to 64, do with me. So we have to arrange ascending order. So here real boundaries are not given. Real boundaries are not given. No? Then you better to get real boundaries. I'm not going to calculate mean. I'm just going to calculate only quartiles and interquartile range. Okay. Then here real boundaries 49.5, 54.5, 59.5, 64.5, 69.5, 74.5, 79.5, 84.5, 89.5, 94.5. Yeah, 54.5, 59.5, 64.5, 69.5, 74.5, 79.5, 84.5, 89.5, 94.5, 99.5. Then here frequency. Then when calculating median, quartiles, we need frequency sum, no? Cumulative frequency, F greater than 3, 10, 25, 63, 104, 139, 160, 186, 190. Something wrong, no? 3, 10, 25, 176, 190, 200. Okay. Then when calculating median, we have to think 100 element. Then here 69, then 100 element here. Then Q2, that means median here, Q2 and median here. Then here this is equal median class. Then 200, no? 200 divided by 4, 50th element will be quartile. Then 50th, here 25, then 50th element here. Then Q1, here Q1 class. Then Q3 class 150th element. Then here 139, then 150th element here. Then here Q3 class. If you are in doubt, tell me. Then here 200, then 200 divided by 200, 100th element is here. 50th element here, 150th element here. Those are quartiles. Then quartiles belongs to those classes. Do up to that. Okay. Now quartile formula Q1 L1 plus C N over 4 minus FC divided by Fn. Here first quartile formula. Now L1 mean first quartile lower boundary 64.5. C class width N over 4, total N mean 200. FC mean up to this class frequency sum, that is 25, no? Addition of this 25. Fm mean frequency of this class 38. Then we can calculate first quartile. We can calculate first quartile, no? We can calculate first quartile. Similarly, if you need to calculate third quartile, then get this formula L1 plus C 3n divided by 4 minus Fc divided by Fm. Now instead of I you put 3. Then 3n divided by 4 minus Fc. Then here this is third quartile. Then L1 79.5 class with 5. Here 200 divided by 4 times 3 minus Fc up to Q3 sum 139. Here 21. Okay, that's it. That is third quartile. Then median calculation we done previously, no? Then this is third quartile, this is first quartile. Then gap will be interquartile range. Q3 minus Q1 value will be interquartile range. Quartile deviation means you have to divide that by 2. Q3 minus Q1 divided by 2. Then you calculate that into one decimal place and do them. Okay, that's how we calculate interquartile range and quartile deviation. So if you need to find range, here these are not real boundaries. These are not real boundaries. You have to take real boundaries. Then lowest element 49.5, highest element 99.5. Don't take this. You have to take real boundaries. Then lowest element 49.5, highest element 99.5. Then range will be 99.5 minus 49.5. Okay, range will be 99.5 minus 49.5. Okay, these calculations are very simple calculations. These calculations are very simple. Then just only you remember equation or formulas, then apply it. That's it. So usually we get mean, usually we get standard deviation or variance. Sometimes we get mode and median, and very rarely we get quartiles, quartile deviations, and coefficient of skewness, and so on. Then pool mean again just rare case. Okay, let's have a small interval. Okay, let's start. Let's start. So now we need to analyze what is mean deviation, what is variance, and what is standard deviation. Okay, then these are another special parameters, but mean deviation will not, we no need to calculate mean deviation, but anyway, we'll see what is mean deviation first. Now this is it. So far we have identified three different data sets now. Three different data sets. Ungrouped data distribution, ungrouped frequency distribution, grouped frequency distribution. Then mean deviation, standard deviation, and variance, all we need to calculate for each case. But frequency distribution, group or ungroup, anyway, frequency distribution, we have one formula. For group frequency distribution and ungrouped frequency distribution, both has one formula. Then ungrouped data distribution has another formula. Okay. Now see mean deviation. Usually we denote by MD, mean deviation. So here x1, x2, x3, xn. Here this is our data set. Then now we know how to calculate mean, no? X bar. Let's say it is somewhere here, mean. Then we have to get difference of each element with mean. Then x1 minus x bar, x2 minus x bar, x3 minus x bar, so on. Then it goes like that, xn times x bar, xn times x bar. Now get only absolute value. Absolute value means only numerical value we need to think. X bar minus x1, x bar minus x2, x bar minus x3, likewise you get all, and its mean value we call mean deviation. Okay. Then further our formula sigma I equal 1 to n xi minus x bar mod divide by n. This is mean deviation formula for ungrouped data distribution. Okay. Then for group frequency distribution, x1 frequency f2, x2 frequency f2, so on xn frequency fn. Then frequency distributions, for frequency distribution, so each case we have frequency, no? Each case we have frequency. Then x1 minus x bar times f1, x2 minus x bar times f2, it changed like that. Therefore, here mean deviation now, sigma I equal 1 to n fi times xi minus x bar mod divide by frequency sum, I equal 1 to n. That is for group frequency distribution. This is for frequency distribution. This is for ungrouped data frequency distribution. Then this is somewhat difficult to calculate. Then first we need to calculate mean. Therefore, after each element we have to get difference, and thereafter we need to get mean value. First calculate mean. Thereafter you get differences between each element. Then get absolute value and get mean value. That is mean deviation. Then here it contains only positive value. So here x1 minus x bar can be positive or negative or 0, no? But we can see absolute value, no? We can see absolute value, then positive value, we think about positive value. That means only gap we consider. Then this is not that much good parameter. Therefore, we don't need to worry about calculating this type of parameter. But anyway, just put that one, mean deviation. Just write in separate paper. Mean deviation. Okay. Now here mean deviation. No? Then I told you there's small problem here. We can't see what is whether it is positive or negative. Okay. Therefore, here instead of this mean deviation, we gonna consider about variance. Here very good parameter. So usually denote by S squared. Usually we denote by S squared, variance. Then here it is variance formula. So you forget this absolute value, square it. So when squaring we can get positive and negative value. Then here this will be variance formula. Xi minus x bar divided by n, variance formula. So for group frequency distribution, we can take this one. This is variance formula. But this formula is somewhat hard to calculate. But there's special format to calculate that. There's special format to calculate that. Okay, anyway, just write this variance formula for ungrouped data distribution and for group frequency distribution. Both you write this formula. Now, see for easy calculations, see this one. So, ungrouped frequency, ungrouped data distribution. Ungrouped data distribution. Now, original formula, original variance formula is this. This is original one. Okay. But for easy calculations, we can further simplify that. So see, simplified version, S square equal, here original one, sigma I equal 1 to n, xi minus x bar square divided by n. Here original formula. Then by simplifying, we can get second format, sigma I equal 1 to n, xi square divided by n. This is equal square mean minus x bar square. Here mean square and here square mean. Square mean. Then here second format. Later we will see how to get it. Huh? Then here original one, by simplifying this using sigma notation we can obtain this one. So instead of this we better to use because simplification somewhat easy than the previous one, easier than the previous one. Now further, if we introduce di equal xi minus a, then further we can get easy simplification, then that is s square equal, instead of x you put d, sigma di square divided by n minus d by square. Here third formula. Okay. Then here for ungrouped data distribution. Now see, let's prove it. Let's prove this one. I'm going to prove first one. Here second one. Huh? Here original one, s squared equal sigma I equal 1 to n xi minus x bar square divided by n. This is s squared. Now expand this bracket, sigma I equal 1 to n xi square minus 2 times x bar times xi plus x bar square divided by n. Okay, just expand. Now separate sigma xi squared and separate denominator. I equal 1 to n. Here 2x bar constant, take outside, and sigma xi divided by n. I equal 1 to n plus sigma x bar square divided by n, I equal 1 to n. Now here sigma I equal 1 to n xi square divided by n. 2x bar, this also x bar, no? Sigma xi divided by n mean x bar. Here sigma sum x bar mean constant, no? Then n times x bar squared divided by n. Then by simplifying you can get final version. Sigma xi square divided by n minus x bar square. Here it is. That's how we prove. Okay. Just write them. Just write. First you write here this one relation. First you write relation. Okay. Now third proof. So we need to convert that into di. No? Then here we can't see equation just like same. No? We can't see the calculation. But anyway, here xi value is somewhat larger than di value. Therefore, instead of second one, you better to get third relation. Okay, that one is best good than this two, no? Second one. Okay. Now here, let's take this. Now x square equal sigma xi minus x y square divided by n. No? Then here transformation di xi minus a. Then we know xi di plus a. Then x bar d bar plus a. D bar plus a. Then sigma xi mean di plus a. X bar mean d bar plus a. D bar plus a. Then here we can cancel constant now. Then sigma di minus d bar square divided by n. Then previously we done that simplification for xi here. For xi we done that simplification. Now replace x by d, you follow same procedure. Then you get di square minus d bar square. Okay, that's the procedure. Then here no effect for value addition. Here value addition no effect with variance. Now you think there's a class now already calculated variance. So now if we add constant value for each student, then variance won't change. Variance won't change. Ne? Here no effect with a. But if we multiply, then there will be some change there. Okay. Now you simplify this one and get sigma I equal 1 to n di square divided by n minus d by square relation. Here is square formula. That is third formula. By previous simplification technique, you can do. Okay, do that proof. That is third proof. Okay, then let's see this for group frequency distributions. See this for group frequency distributions. Group frequency. Now there will be frequency, no? Then only Fi you need to add here. Here you need to add Fi. Then this change here divide by n means sigma Fi. Then here this change Fi xi square divided by sigma Fi minus x bar square. Then when we put di variable, then it changes like this. Sigma fi di square minus d by square divided by n. Okay. So here there's coordinate method again, yi variable, xi minus a divided by c case. Then here the easiest one. So we're going to use this s square equals c square times sigma fi yi square divided by sigma fi minus y by square. Here fourth formula. Here the easiest one. I told you when you are doing mean, I told you to put this column fi yi square column. Then using that we can get addition. Okay, write that one as well. Write that one. Now see variance calculation and standard deviation calculation. 2023 question, 2023 question. Here the table, no? So we done up to this, no? We done up to this. fi yi, then fi yi, then fi yi squared. Then y bar mean sigma fi yi divided by sigma fi. Then sigma fi yi, it is 10 divided by 100. 1 over 10. Sigma fi yi. Then variance mean c square sigma fi yi square divided by sigma fi minus y by square. This is variance. Then C mean class with 10. Sigma fi yi square, here 120. Sigma fi mean frequency sum 100. Y bar mean 1 over 10. Sigma fi yi over sigma fi. This is it. Then this is very simple calculation. 120 minus 1, 119. Here variance. Then standard deviation 119 root. Then you obtain for one decimal place here. That's how we calculate variance. Okay. Then very simple calculation. Very simple calculation. Only when we get in standard deviation, then here we need to get a square root now. Then we have to get value approximately one decimal place here. Okay. Do that calculation. Then let's do 2022 variance calculation. No need to read the question, later we will read and do. Now just practice it, variance calculation. So if you have done that table previously, you get the value and just substitute. Continue. Yeah, this is maximum requirement. Your maximum requirement. You have to find xi, you have to find yi, you have to find fi and you have to find fi square. Then need addition sigma fi, sigma fi, sigma fi square. Then substitute to the formula. Na? Y bar sigma fi yi divided by sigma fi minus 3 over 20. Then variance c square sigma phi yi square divided by sigma phi minus y bar square. Class with 4 sigma phi yi square 21 y bar minus 3 over 20. Now just simplify. Find approximately 1 decimal place. Then standard deviation, square root of this. Standard deviation. These parameters are too difficult to analyze. Huh? We can't understand easily. Okay, then you try 2019 question. 2019 only variance calculation enough. No need to read and just get the table and complete it. 2019 question. 2019. Okay, then y bar sigma fi yi over sigma fi minus 7 divided by 50. Variance sigma fi yi square divided by sigma fi y bar square. C mean 10. Sigma fi yi square 81 over 50. 7 over 50. Get the value. Here these calculations are not that much hard. Complete. Okay, then definitely you will get mean, variance or standard deviation. Variance or standard deviation. Okay, very simple calculation. Now we have to analyze only further parameters. So now we have done lot. Now we have to do only pool variance and shape of the distribution and z-score. Okay. Now let's do them. Check this one. Here shape of the distribution. We analyze that one by skewness. Shape. Distribution. Skewness. So we know how to sketch histogram now. Then using that we can sketch frequency polygon. So if we smooth that one, that can be here this shape. That can be this shape. Sometimes that can be here this shape. It is symmetrical type. Here it has tendency here left hand side. Okay. Here it has tendency to right hand side, like this. Then here this distribution we call positive skewed. Here symmetrical. Symmetrical distance. And this is called negative skewed. Negative skewed distribution. That is the shape. Then usually this case, so here mod, then appear median, then appear mean. Here mod, then median, mean. Here this case, mod lower value, then median, then mean. For this case, mean, median, mod coincident. Mean, median, mod coefficient, all are coincident. X bar, ME, MO coincident. No need to remember these things. You just need to remember what is skewness and what is positive, what is negative. That's it. Then here, this case, this is mod. Then median somewhat less. Mean again some are less. Mode, median, mean. So here shape of the distribution. Then without checking this graph, we can analyze using coefficient of skewness, Karl Pearson's coefficient of skewness. Coefficient of skewness. We denote by Sk. Here you have to remember Sk value 3 times x bar minus me divided by s. Here by this one you can see what is that shape. Okay. Here using frequency polygon we can analyze what is the distribution shape, or otherwise here there's formula Karl Pearson's coefficient of skewness. So you put x bar, me and s value, then we get positive value or we get negative value or we get 0 value. Then if we get positive value, positive is skewed, positive is skewed. Here negative is skewed and here symmetrical distribution. This is another new parameter, coefficient of skewness. Here shape of the distribution, that, okay, just write that one. Okay, then next parameter Z score. So here we have values x1, x2, x3, xn. So that can be group frequency distribution or that can be just ungrouped data distribution, whatever it is, okay. Now we can calculate mean. We can calculate standard deviation. Here standard deviation. Then Z-score formula xi minus x bar divided by s. Here you select one person, that is xi, take his value, put it here, then here average value, put it here, and here standard deviation. This is we call Z-score. You have to remember only formula. Okay. Then consider numerical value 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then mean value 1 plus 2 plus 3 plus 4 plus 5 divided by 5. Here 6, 12, 15, now 5, 3. Here mean value 3. Then here take this person A, then ZA 5 minus 3 divided by S. 5 minus 3 divided by S. That means 2 divided by S. Then we have to calculate S, standard deviation. Then standard deviation, before that we have to calculate variance now. We have to calculate variance first. So see, variance formula sigma xi square divided by n minus x bar square. Then square mean 1 square, 2 square, 3 square, 4 square, 5 square divided by 5 minus here 3 square. Now simplify 1, 4, 9, 16, 25 over 5 minus 9. Further simplify. Here 20, 29, 30, 55 over 5, 11, 11 minus 9, 2. Here variance. Then standard deviation root 2. Then instead of S you put 2 divided by root 2. Then we get answer 1.4. Root 2 no? Likewise we can get standard Z-score. Okay, that calculation, Z-score calculation. Okay, do that parameter, write that parameter. Then these are too difficult to understand. We can't analyze the property here. For up to now, in our A levels, we can't analyze about this, what has happened there. But anyway, xi minus x bar mean, x bar mean, then xi minus x bar mean difference between our value and average value. Then if this one greater than x bar, then we get positive z score, positive z score. Then here S mean standard deviation. So according to variance mean it's something like variation. It's something like variation. So standard deviation is square root of that. Then here we check about variation. So when we divide by variation, then difference divide by variation, something like that. Therefore, here this effect that goes to variation into denominator. Therefore, xi minus x bar divided by s. We analyze about stability. Making stability එකක් තමයි check කරන්නේ. ඒතර stable ද නැද්ද කියන එක තමයි check කරන්නේ හැම එකෙම. Okay, Z score. Write it. Now let's come to last one, pool variance. Now check this. We're going to add two or more distributions. Here one, we have calculated mean and variance, standard deviation, standard deviation, mean and standard deviation. Now we know how to get pool mean. This is pool mean. We done that before. Then pool variance formula. Later we will prove this. Here, when we gather these data set together, then we get a new data set. Then its variance given by 1 over s square mean variance, 1 over n1 plus n2 plus n3 into n1 times d1 square plus s1 square. Second set n2 times d2 square plus s2 square. Third set n3 times d3 square s3 square. Then we know n1, n2, n3 they are given. S1, S2, S3 they are given. Then D1 mean, here new mean, subtract with this x bar minus x1, that is D1, x bar minus x2, D2, x bar minus x3, D3. Then you remember this formula and substitute the data. Therefore, finally you can calculate pool variance. This is we call pool variance. So we have to gather two or more data sets using this formula. Okay. Put that one as well. So I think page number 8 or 9 we have a space there. Last theory page. Now that's all about statistic, but we need to prove this relation. Later we will prove that. Then we know how to calculate different parameters. Especially you need to remember mean and variance and standard deviation. Then mode, median, in some cases quartiles, and remember these parameters first. Then shape of the distribution, sometimes there will be in your exam question. Z score. Then pool mean, that means collection of two or more data sets. You have to remember these parameters. Okay, and that's all about statistics for today.